Today's topic is subnet masks. Most of the people doesn't have a clear idea about subnet masks. I will illustrate it through a practical base so that you grasp the idea of subnet masks. So let's start. Let's have an idea about IP address. An IP address consists of 4 numbers separated by 3 dots. This 4 number can change from 0 to 255. That is, the first number can change from 0 to 255, second number also 0 to 255, third also 0 to 255, and the fourth also 0 to 255. That is, in this example, the fourth number of the IP address changes from 0, 1, 2 up to 255. Now the manager of your company tells you to perform a task such that the IP address whose fourth number starting from 0, 1 up to 255 can communicate each other. They can share file and printer among them, but they cannot access other network other than this network. That is, the IP address ending with 0, 1, 2 up to 255 can communicate each other. Then how to perform such tasks? Such tasks can be achieved by the help of subnet masks. Then let's learn how to achieve such tasks by the help of subnet masks. Simply by giving number 0 on the fourth number of the subnet masks. This 0 indicates that IP address ending with 0, 1, last number IP address last number ending with 0, 1, 2 up to 255 can communicate with the they can share file and printer among them. 0 indicate this task. Now the manager tells you that 0 up to 127 can communicate each other, and 128 up to 255 can communicate each other. They can share file and printer among them. Then how to achieve this? By simply changing this subnet mask value to 128. 128 means 0 up to 127 can communicate each other. 128 up to 255 can communicate each other. That is, dividing the IP address into half. Now you got the idea that about subnet masks. Subnet masks is grouping the IP address, grouping of IP address, such that they cannot communicate another network. There are two group of IP address, 0 up to 127 in this case, and 128 up to 255. 0 to 127 can communicate each other, 128 up to 255 can communicate each other, but these two group of IP address cannot communicate to each other. So the main function of subnet masks is grouping IP address. Now let's learn how this number is derived. Subnet mask notation is identical to that of IP address. That is, it consists of 4 numbers. In order to store this first number, there are 8 bits of memory reserved for storing this number. In the same way, there are 8 bits of memory is reserved for storing this second, third also 8 bits, fourth also 8 bits. Altogether, 32 bits of memory is reserved for storing the subnet masks. Now let's learn how many more numbers or value are there representing subnet masks. We know that there are 8 bits of memory reserved for storing a number. So in order to store this 0, there are 8 bits of memory reserved for storing this number, and there is a corresponding value for every bit. First bit has a value 1, second 2, then 4, doubling. So 8 doubling 16, 32, 64 and 128. Now the subnet mask value will be, first will be 128, next will be 182, summing 128 plus 64 will be 182. Next will be 224, summing these 3 numbers. 240 will be summing up to these numbers. 248 will be achieved by summing up to this number. 252 will be achieved by summing 128, 64, 32, 16, 8 up to 4. 254 can be achieved by summing up 128 up to 2, and 255 can be achieved by summing 128 up to 1. So the subnet mask value will be consist of 9 numbers. First is 0 and this 8 number. So subnet mask value can be either this 8 numbers plus 0, altogether 9 numbers. Now what this subnet mask value 128 means? 128 means it can communicate 128 IP address or 128 computers, and if it is 192, it can communicate 64 IP address or 64 devices, and if it is 224, it can communicate 32 computers, like 32 computers or 32 devices. If 240, subnet mask value is 240, then the number of IP addresses that can communicate each other, that is file and printer sharing, can be performed is 16. In the same way, 248, 8 IP address, 252, 4 IP address, 254 will be 2 IP address, and 255 will be 1 IP address. When we convert this 128 into binary, it will be like this. 128 is decimal, that is all these numbers are human readable numbers, but computer doesn't know this number, so they know only binary. When we convert this 128, it will be like this. Next number will be like this, incrementing the number of 1. First number 1 is 1, second is 2, third is 3 numbers, 4 time, 1 5 time, 1 6 time, 1 7 time, 1 8 time. So the computer knows only these numbers. This number can be understood by the human, and this number can be understood by the computers. 1 is known as the network ID and 0 is known as the host ID. Now let's learn what is network ID and host ID. Network. How many number of 1? There is only one, so 2 to the power 1 equal to 2. The number network is 2. What does it mean? I will clarify it. So if the subnet mask value is 128, so subnet mask value is 128, the number of IP address that can communicate is 128. So 0 up to 127, summing up together 128 number of IP address that can communicate each other, file and printer sharing can perform. Here is 128 numbers of IP address. In the same way, 128 up to 255, the number of IP address is 128. There are two networks. 0 up to 127 is the first network. 128 up to 255 is the second network. So altogether there are two networks. So the network here is this 2 is this one, first network and the second network. So in the same case, if it is the subnet mask value is 182, then the number of network will be 4. If it is 224, the number of network will be 8. If 240, the number of network will be 16. If 248, the number of network will be 32, and 252, the number of network will be 64. In this way, it will continue. Now let's learn about number of hosts. Here I have already said that 0 is the host ID. So number of 0 here is 7. So 2 to the power 7 equal to 128. That is 128. So the number of what does it mean? I will clarify it. Let's think. If the subnet mask value is 128, the number of IP address will be 128. They can communicate is 0 to 127. When sum up 0 up to 127 is equal to 128. This is known as host. 0, 1, 2, 3 up to 127. This is known as host. So if the subnet mask value is 128, the number of hosts will be 128. Means 0 up to 127, summing up 128. 128 up to 205, the number of IP address that can communicate is 128. If it is 192, it will be 64. Number of hosts will be 64. It will continue like this. So that is number of to the power number of zeros, to the power number of, here is 5 to the power 5, to the power 4, to the power 4 here means number of zeros 4. In this way the number of hosts is calculated. Now let's learn about some do's and don'ts of subnet masks. Look here, 25 consists of 1 time, 25 consists of 2 times, 25 consists of 3 times, and 0 consists of 1 time, 0 consists of 2 times, and 0 consists of 3 times. So 25 and 0 can consist 2 times, 1 time, and 3 times, but this number cannot consist even 2 times. Look here, it consists of 2 times, so it is wrong. And in this case there are the numbers different, 192 and 128, so it is also wrong. So this value can be consist only 1 time, so I have taken here 128, so it can consist only 1 time. It cannot consist any even 2 number. But 255 and 0 can consist 1 time, 2 time, and 3 time, but this number cannot consist 2 times. It must be consist only 1 number only. Default subnet mask of class A means 1 time, 255 1 time, that dot 0 dot 0 dot 0. B means 255 2 times, then 0 dot 0. C means class C means 3 times, 255 3 times dot 0. What does it mean? Default subnet mask mean, if the IP address is class A, then its subnet mask will be 255.0.0.0, and if the IP address is class B, then its subnet mask will be 255.255.0.0, and it is class C, then its subnet mask will be 255.255.255.0. If a device wants to communicate a PC having this IP address and the subnet mask this one, then how this process is performed? The router will first check the subnet mask. After checking the subnet mask, the router will identify this is a network ID and this is the host ID. So the router will have an idea that up to this is the network ID, and after this it will check the subnet mask number of this host ID 128. It means that the first ID will be 0 and second network ID will be 128, and this 5 falls in the 0 network. So the network ID of this machine will be 192.168.0.0. So 192.168.0.0 is in this network. After this, having identical network address, then the router will request the broadcast address to broadcast in this network, that which is the PC having this ID 5. So it will broadcast in this network, and the PC having this ID 5 will say that it is me. Then the connection will establish and file and printer sharing will be performed.